These two hidden planets lie in the dark zone, just 16 light-years away from us, possessing temperate climates but overlooked in previous astronomical surveys. Surveys using the radial velocity method and transit observations have detected over 5,000 exoplanets, including Earth-like planets located in distant regions of the universe. However, in a world just 16 light-years away, orbiting the faint red dwarf star Gliese 1002 in the constellation Cetus, the space is too dark for the above measures to be effective. In a recent survey led by Dr. Alejandro Suárez Mascareno from the Instituto de Astrofísica de Canarias, Spain, 2 state-of-the-art instruments, the Espresso and Caminus spectrographs, were used. The Canarias and Calar Alto observatories in Spain were successively used to explore the dark region around this red dwarf star. They focused their research on the area near the star because red dwarfs have much lower temperatures than the Sun, causing the Goldilocks zone to also be closer to the parent star. The results were truly astonishing. They discovered not just one but 2 planets, named Gliese 1002b and Gliese 1002c, coexisting harmoniously within this habitable zone. Not only that, but these are also planets of the same type as Earth, only slightly larger in size, with masses 1.08 and 1.36 times that of our planet, respectively. After cross-referencing with other data sources, scientists determined that these planets have temperate climates. That means it is entirely habitable and capable of sustaining life. A counter-argument to the possibility of life existing on these planets is that red dwarfs often emit intense radiation. This will make life difficult for the creatures living there, if they truly exist. However, many studies also show that certain life forms can resist or avoid radiation. For example, living in underground water pockets or beneath the Earth's surface, much like many extremophiles on Earth. Astronomers are pinning their hopes on several advanced devices currently under development for the future. Like the Andes spectrograph or the LIFE mission that European scientists are rushing to prepare for the announcement day. The origin of the largest galaxy in the universe. About 3 billion light-years from Earth. Scientists have just discovered the largest structure ever known in the universe. The giant radio galaxy outside Onius spans up to 16.3 million light-years in size. Named after Aleranos, the son of the primordial Greek god who ruled the sky. Onia's exterior may reveal new clues about the structure of the universe. Often referred to as the cosmic web, this is considered the structure that connects all galaxies together. A radio galaxy consists of a main galaxy, the center of which contains a supermassive black hole. When matter is pulled into a black hole, it releases energy from the galactic center, generating massive energy jets. These energy rays then interact with the intergalactic environment within the cluster. In this process, the electrons are accelerated and emit radio waves. These signals can travel a very long distance before expanding into massive radio waves. Astronomers at the Leiden Observatory in the Netherlands say this is a common process, even for our own Milky Way. However, what puzzles them is why in certain galaxies, these radio waves can reach such enormous sizes. Mr. Martin Oye, the research team leader at Leiden Observatory, said, "If the distinctive features of the host galaxy determine the enormous size of a radio galaxy." Here are the natural English translations of the given Vietnamese text. In addition to intrinsic factors such as the characteristics of the host galaxy, external environmental influences also play a significant role in determining the size of a radio galaxy. Similarly, if there are specific environmental conditions that facilitate the formation of giant radio galaxies, the largest radio galaxy likely exists there. To delve deeper into outside Onios, astronomers utilized the Slow Digital Sky Survey observation system, located at the Apache Point Observatory in New Mexico, to observe the host galaxy. They observed that this is a fairly typical elliptical galaxy, with an estimated mass roughly 240 billion times that of the Sun. With a supermassive black hole at its center, it has a mass roughly 400 million times that of the Sun. The research team confirmed that both of these indicators are at low levels compared to typical giant radio galaxies. This could reveal some important clues about the formation and development of radio waves. The researchers noted that outside Onios and the galaxy containing it appear suspiciously ordinary. The metrics such as total low-frequency brightness density, stellar mass, and supermassive black hole mass are all lower than or comparable to those of typical radio galaxies. Therefore, the host galaxies or central black holes are not the main factors causing radio galaxies to reach such enormous sizes. Currently, the most convincing reason the research team presents is that outside Onios exists in a region of space with a lower than average matter density. This galaxy is endlessly expanding at a staggering speed. It is also believed that outside Anyos continues to grow and become even larger. To detect outside Anyos, the research team used data collected from the Low-Frequency Ray Network, abbreviated as LOFAR. A network system consisting of approximately 20,000 radio antennas deployed across 52 different locations throughout Europe. Scientists have discovered two massive plasma jets erupting from a supermassive black hole at the center of a galaxy. These two streams of matter shoot into space, carrying the elements that form a new star and traveling at speeds approaching that of light. This material heats up and turns into plasma, emitting light in the form of radio waves that the LOFAR system can detect. The James Webb Telescope captures images of distant galaxies and star clusters. As a member of the High Dong star cluster, the galaxy pair ZV296 is in the process of merging and is extremely chaotic, with regions of star formation resembling glowing threads connecting the cores of the two galaxies. The spiral arms of the smaller galaxy are distorted by gravitational disruption. NASA stated that it is the presence of star-forming regions that makes ZV296 an appealing target for the James Webb Space Telescope. In the latest observation, the Webb telescope used two instruments, NIRCam and MIRI, to capture this violent collision in infrared wavelengths, delivering an unprecedented level of detailed and authentic perspective. The ZV296 system emits extremely intense light at infrared wavelengths due to the explosion of young stars, with a brightness exceeding 100 billion times that of the Sun. The moment the Webb telescope was launched into space, astronomers worldwide immediately proposed studies on complex galactic systems. The passage includes the event of galaxy mergers such as ZV296. With the ability to magnify 100 times more than the Hubble telescope and technology that observes back in time to the past, the website promises to clarify the intricate details of the galactic environment while offering profound insights into the distant universe.